Alright, so in this video we're going to touch on how to do some calculations with these solutions we've been talking about this unit. This is going to cover all of page 11. There are two different types of calculations we're going to do, this top half and bottom half, but we are doing both. And as always, I'd encourage you to have a calculator to follow along and try these calculations out to make sure you can make sense of the numbers I'm putting on the screen and get the same answers, because if you're not, I want to help you with that. So, this thing we're going to be calculating first is called molarity. Molarity is a measure of the concentration of a solution. It tells us how much stuff is dissolved in a certain amount of solution. Think of this like when you're making Kool-Aid. You could take the same exact amount of Kool-Aid powder and dissolve it in a small amount of water versus a large amount of water, and that Kool-Aid would taste different because it has different concentrations. The Kool-Aid powder that you dissolve in less water is going to taste sweeter than the one that you dissolved in more water, even though you put the same amount of sugar, the same amount of powder into that Kool-Aid. So that's because even though you had the same moles of solute, the same amount of stuff being dissolved, when you divide it by the volume that you're using to dissolve it, that makes the overall molarity or concentration smaller. So that's what we're calculating here. Molarity, which is represented by this big M, is equal to the moles of solute, the amount of stuff we're dissolving in the solution, divided by the total volume of the solution. Now, there's a lot of kind of stuff written here. The simplest version we can make this equation is just big M equals moles divided by liters. And this is actually on your equation sheet, so you do not have to memorize it. It's just right down here in the solutions area, M equals moles over liters. It even reminds you M is molarity, which is a measure of concentration. V is volume. Oh, I guess we'll get to the V later, because it's actually very important that this does not just say V here in our equation. This is liters, and it has to be liters, cannot be milliliters. So just like in our gas unit, sometimes we had to turn things into liters from milliliters, and whatever milliliters number you're given, you just have to take that number divided by 1,000, aka you'd be moving that decimal left 3 times. So in the first problem, we're going to see 355 milliliters, where the decimal's understood to be there at the end. We're going to be turning that into liters first thing, and that's going to be 0.355 liters of our solution. Now, for that matter, these moles have to be moles as well, of course. There wasn't really much debate on that. But keep in mind that if the problem gives you grams, you can turn our grams into moles using a little bit of dimensional analysis in order to get these moles, of course. And the same skill we've been using over and over again. Now, sometimes you might be asked to solve for something other than just molarity using this equation. And in that case, we have a little triangle method for rearranging this equation. Our moles over liters is what's always equal to molarity. But by setting up this triangle the way that we have, whatever we're looking for, we can kind of cover up or get rid of in our triangle, and what's left behind is our equation. So if we wanted to calculate our moles, that would equal our molarity times the liters of solution. If I wanted to calculate the liters of solution, cross that out, ignore it. What's left behind is moles over molarity. So if I want to find those liters, then I can do the moles I'm given divided by molarity. You will be responsible for rearranging this on your own if you need to solve for anything other than molarity, because only this original equation is given to you on the equation sheet. So here in our first question, this is asking us to calculate our molarity. So we are going to be dealing with that original variation of our equation, just the normal one. We just need moles and liters in order to do this division. And like I said before, when we see these milliliters and we need liters for our equation, we should move the decimal 3 times to the left. So that becomes 0.355 liters. And then we're given grams here, not moles, so we're going to have to do a little bit of work to turn those 40 grams into moles. I just have to add up all of this C6H12O6 stuff from the periodic table, which ends up being 180.156. I put that number on the bottom so we can cancel out the grams that we have here. Grams and grams diagonally from each other going away. What we're left with is moles and a specific number of moles of 0.222, keeping 3 sig figs because we had 3 sig figs here. So just a little bit of side work there before I bring that number up. And then my final division here, when I do that, 0.222 divided by 0.355 gets me 0.62535. And I would once again be wanting to keep 3 sig figs. Remember, that first 0 doesn't count as a sig fig. So my final answer would be 0.265. Because I was solving for molarity, my unit is big M. And that's just about as tough of a problem as we can give you with molarity, where you got to do a little bit of grams into moles and a little bit of liters into milliliters. The only thing else we could throw at you would be maybe having you rearrange an equation at the same time. So let's see a couple other variations here. In the second one, it's asking us to calculate mass. Keep in mind, that means we're looking for grams, and this equation doesn't have grams in it. But hopefully, when in doubt, if we want grams, the first thing we're going to have to solve for is moles, which means we're going to have to take our molarity times the liters of our solution to get those moles. But those numbers are just waiting for us right there. Molarity, and our volume is even in liters already, so we can find our moles really, really quickly. That's 4.375, which would turn into a 3 sig fig 4.38 moles. And now I just have to figure out what this barium nitrate is, and I'll help you out with that. I know some of y'all still struggle with formulas. This is just barium and nitrate. Barium's +2 charge crossed over, which is why we got that 2 there. Nitrate was just a -1 charge. So this is barium nitrate. So we're adding up 1 Ba plus 2 Ns plus 6 Os in order to get a final mass here. And the 1 mole part of that is going on the bottom this time because the mass, that 261.336 that I just had to add up from the periodic table, needs to go on top because I want to be ending up with these grams here. So this final answer ends up being 585.795, and I'm sure that's a little bit more. Oops, my bad. I had a typo there in my calculator. So hopefully that was seeming kind of wrong to you, a little bit too small. This is my actual unrounded answer, which if I wanted to keep 3 sig figs, which I should be, would actually end at 114, fill in that empty space with a 0. So that's going to be 1140 grams of barium nitrate. So this next one is going to ask us to calculate the volume of water. And remember, volume is measured in liters, so we're going to need our liters equation here, which is moles over molarity, in order to do this calculation. And all of the numbers you need are right here in this problem. So I'm actually going to have you finish this one out. I do not want you to leave this blank. If I don't see some kind of more work with numbers plugged in together here, I'm not going to be stamping your packet. Should end up with a very reasonable amount of liters as your final answer here. So go ahead and give this one a quick try. Find that answer. If it's not right, we can work on that together in class. But let's go ahead and jump to this very last one, where it asks us to calculate molarity again. So we're going to be using our normal old molarity is moles over liters. And this time we have 15.5 grams of silver nitrate, which is AgNO3, dissolved in 250 milliliters. So a lot like our very first problem. We're going to have to turn these grams into moles and these milliliters into liters here. And if we work on that, let's do our grams first, since I'm seeing that number first. Adding up our AgNO3 from the periodic table gets 169.872. So that's going to give us 0.0912 moles. And then our liters, after we move this 3 times, is going to be 0.250. So doing that division is going to be 0.3648. And our final answer should then end up being 0.365 is our concentration, is our molarity. So hopefully this type of problem isn't too bad. The worst it can get is some grams involved, so some dimensional analysis at the beginning or the end, but not always, not if it doesn't mention grams in the problem. Now, our second type of problem is called a dilution problem. And a lot like when you're making your Kool-Aid, you might be diluting it. If you have a solution, stuff already dissolved, you say, oh, this is too sweet, you could add some more water and dilute it. And we're actually going to be doing calculations of how much water or how much concentration we're going to have either before or after diluting it. This equation is also on your equation sheet, so you do not have to memorize it, you just have to be able to use it. And this is really why we have that M and that V over there reminding us what the big M and the V mean. And this equation, a lot like the combined gas law last unit, has a one side and a two side to help us compare the molarity and the volume of the first solution, generally before we dilute it, to the molarity and volume of the second solution. So it doesn't really matter which side the numbers go on, as long as you make sure that the molarity and volume that you're given before go together. Whether it's on the one side or the two side, it's really important you get them on the same side. And just like in that gas law unit that we did, a big way, an easy way to rearrange any equation where everything's just all in one big straight line is this idea that the unknown, whatever you're looking for, is going to be equal to whatever's on the opposite side of the equal sign, the whole side, divided by whatever's on the same side is what we're looking for, opposite over neighbors. And if I do that for each of my variables, the M1, the V1, the M2, and the V2, one thing that I want to point out to you, and you really shouldn't have to write all of these down, notice that if I'm looking for M1, M2 and V2 are being multiplied. V1, M2 and V2 are being multiplied. And the same is true on the opposite side. M1 and V1 are being multiplied. We're always multiplying together whichever numbers we have both of, and then dividing by whichever side we only have one of. And that's really how I work these problems out. If we look at the very, very first, just reminding you of that same idea. The very, very first problem of this type, notice that it's saying what concentration results when water is added to 500 milliliters of a 12 molar hydrochloric acid solution. This is our V1 and our M1. They're going to go together, and then this 2 liters is the V2 technically, but all I need to keep down is that I'm going to be multiplying these numbers that go together and then dividing by this other one. Technically that means M1 times V1 divided by V2. But we don't even have to change our volume into liters. We can just leave it whatever volume we're given, as long as they match each other, which actually I guess they don't here. So we will need to practice turning that into liters, I suppose. As long as they match, we're fine. So changing this into liters, just so it'll match these liters that we have there. So 12 times 0.5 divided by 2 is going to end up being 3. I'm going to make that a 3 sig fig 3 because that's how many sig figs each of my other numbers had there. So in the rest of these problems, our volumes do already match, or we're solving for volume, so it's going to match. So all we got to do is pull out the numbers that belong together, multiply them together, divide by the third number. So as we're looking at number 6, a 3.3 molarity solution is diluted by adding 35 milliliters of distilled water to 50 milliliters of the solution. So we're going to be saying that 50 milliliters of a 3.34 molar solution is what we're starting with. And then I'm adding 35 milliliters. That means my final volume of my final solution, my actual V2, is going to be 85. So here I'm going to be taking my 3.34 times my 50 and divide by 85, and that ends up being 1.9647, but I'm going to stop at 3 sig figs molarity since I'm calculating concentration. Next problem asks how many milliliters of a 12 molar HCl solution and how many milliliters of water, so we'll get to this second, need to be mixed to make 750 milliliters of a 1.1 molar solution. So even though this is the stuff we're ending with, this is technically the V2 and the M2 that I want to end up with from this initial M1. Doesn't matter that it's the ending numbers. Multiply them together. I think that's 750 times 1.11, and we're going to be dividing by that 12, and that's going to tell us that we need to make this a 69.4 milliliter solution. We need to start with that much of our 12 molar HCl in order to make this final solution. But keep in mind, we're only starting with 69.4 milliliters of solution, and we're going to be making that into a 750 milliliter solution. And the only difference between these two volumes, our V1 and our V2, is that added water that we're using to dilute the original solution. So the way we can find our volume of water is just by taking our V2 minus our V1, the final solution with the bigger volume, that's 750, minus the 69.4 that we were starting with. And that's going to tell us that we should be adding 680.6 milliliters of water to make that 750 milliliter solution. Now, as a chemist, we'd probably just start the 69.4 measured pretty exactly and then just put it in a container that we can fill it all the way up exactly to 750 milliliters. But we could do it either way, by pre-measuring the water or just adding it till we get to that set volume. But that's all the calculations that we're doing for right now. Hopefully this second type is even easier than the first. Just got to read your questions carefully, figure out what numbers go together.